Hi Math9 students, welcome to 6.2, and today we're going to be talking about solving equations using a balanced strategy. So this is just another pictorial method, kind of like the bubble version we used yesterday. And excuse me. So what we're going to use is a balance scale, and we just kind of draw them and make sure that we do the same thing to each side so that the scale always remains right in the middle. So for example, if we're solving 6x plus 2 equals 10 plus 4x, we can draw ourselves a little set of scales. Get my pen here. Little set of scales. Maybe not the prettiest thing in the world, but that'll do. And then we're going to have 6 x's and then 2 constants on one side. So you don't have to use the same shapes as you do in the algebra tiles. But you certainly can if you want. So let's just look at the 6 x's. They didn't run out of room here. So there's 3, 6 x's. And then our constant is 2, positive 2. So there'd be there. And then we also know on this side we've got 4 positive x's. 4. And then we've got 10 constants. So we got 1, 2, 3, 4, 5. Another row of those. There we go. So we know that that is a balance. So the whole point of this is it's balanced in the middle here. So if we do something on one side, we have to reflect that on the other side. Otherwise, your scale comes out of balance and one end goes up and the other one goes down. So we have to look at what do we have on both sides of this equation so that if we took them out, it wouldn't actually impact the balance. So to start with, well, if we take away 4 of these positives on this side, whoops, that. We take away 4 of these positive x's on both sides. So if I take away these 4, and I take away these 4, that little piggy tail just means get rid of, then technically I've still got the same amount of things in my basket, right? I just got rid of 4 from each side. So we should still be in equilibrium. So I'll just draw sort of our revised scale now, reflecting those changes. So if I got rid of 4 from the left side here, that leaves me with only 2 left. And I've still got these 2 constants. And then on this side, I took away all of the x's, but I still have 10 of these constants left. And we're still in balance because we removed the exact same thing from both sides. So now, what we want to do is we always want to isolate the variable, right? Well, the variable is going to be these blocks, right? Because those are the x blocks. So we need to have the variable on one side, and then we need to have all the constants on the other side. And these are the constants, the little squares, right? So what we need to do is we need to take these 2 off this side, and if we can take 2 off the other side, now we're in really good shape. So let's take 2 off both sides and let's see what we're left with. Now we're left with just the 2 x's on this side. And then we've got, well, we had 10 and we took away 2, so now we've got 8 on this side. And we're still in balance because we've always removed the same amount of things from each side. Now the last step is you just got to sort of line it up so that each x is responsible for one row. And it's kind of already done here. I could represent it. We're really done at this point because we've got 2 x's equals 2 rows of 4. So then we know that each x has to represent 4. But you could represent it a slightly different way if you so chose, just to keep it perfectly clear. And that would be, say, put 1x lying this way, 1x lying this way, and then put 4 constants across from each of the sideways x blocks. And then what that represents there is that each one of these x blocks, okay, is equal to 4 of the constants. So we can write that now as x equals 4. And then algebraically, on the other side, 6x plus 2 equals 10 plus 4x. Our goal always to isolate the variable and keep it positive. Well, if we're going to keep our x's positive, we've got to bring the 4 to this side, the 4x rather. So if I'm going to subtract x from both sides, that one cancels out, and I've got 6x minus 4 is 2x. Okay? And then I've also got to get the numbers, the constants, on the other side. So in order to do that, I've got to subtract 2 from each side, cancel this one out, and then I've got 10 minus 2 equals 8. Divide those both by 2, and I'm left with x equals 4, which is exactly what we got in the pictorial version. Now for our check here, it says to remember to choose 3 numbers to verify the solution. And frankly, I don't know why it says that. That must be misplaced from another notes package. What it should say is check both sides of the equation. Obviously, my pen is not participating well today again, but so let's check both sides of the equation. So on one side, we had 6x plus 2, and on the other side, we had 10 plus 4x, and we said that x has to be 4, so that's why we can't choose values. We've just got to check both sides of the equation. Okay, so really what we're checking here is this equals? Or is this equal? So 6 times 4 plus 2, and then over here we've got 10 plus 4 times 4. So that's 24 plus 2, and this is 10 plus 16. And what we've got over here is 26, and what we've got on the other side is 26. So that is a check. So really we've kind of checked it twice, because we did the algebraic version and we got the same as the pictorial version. And then we checked it on both sides of the equation with what we think is the answer, x equals 4, and it checked out again. So just check both sides of the equation, and that'll be your verification process. All right, for example 2, we're going to use a slightly different method. Excuse me. It's still pictorial, but we're going to use the traditional algebra tiles on this one, and then we'll also provide an algebraic solution on the other side. So let's just look at both sides of the equation. We've got a negative 3c plus 7 equals 2c plus 8. So I'm going to draw the negative tiles in red, and I'll shade them in. So we've got negative 3c over here. Okay, I always shade in my negative tiles. And plus 7, so that's going to be a positive. 1, 2, 3, 4, 5, 6, 7. And then on the other side of the equation, I've got 2c, both positive, so there's our 2c's, and then I've got negative 8, so these ones are going to be colored in. 2, 3, 4, 5, 6, 7, 8. Okay, and these ones need to be colored in because they are negative constants. So we basically just rewrote our equation using the algebra tiles that we know and love. So what do we do from this point? Well, we've got to find a way to balance this equation using the tiles that we have. And in so, using the tiles that we have, we are going to have to decide what stays and what goes from each end, and how are we going to make it so that we've got a final sort of picture of what each one of these C tiles is worth. Okay, so how are we going to do that? Well, if we've got a negative 3c on one side and a positive 2c on the other, I mean, we can either bring tiles over here, or we can bring tiles over there. So in this case, we've got more tiles over here. Let's just try to get rid of the tiles on this side by adding in 2 negative tiles. So sure you'll agree, if I intentionally put in 2 extra tiles on this one, 2 negative tiles, then what that's going to do is that's going to cancel out these guys. But I can't add 2 negative tiles over here without adding 2 negative tiles on the other side. So I'm going to do that. So I haven't actually changed anything with regard to the total number of tiles I have on each side of the equation. I've just added 2 negatives to get rid of the ones on this side, because I want to have all my C's on one side, right? So those are each negative C tiles. It doesn't do me any good to have negative C's on this side and positive C's on this side, or frankly to have negative C's on both sides. I want to get all of those C tiles, whether they're positive or negative, on one side. So that is, isolating the variable is essentially what we're doing here. And in this case, the variable has a coefficient, right? Because it's not just one C tile or one negative C tile, it's 5 negative C tiles. So it would be negative 5C. So we've got a variable and we've got a negative 5 coefficient in front of that variable. All right, now we've got all of our C's, or our negative C's, to one side, which means we also want to get all of these positive constants over to the other side, because we want to have our C's on one side and our constants on the other. So how am I going to get rid of 7 of these? Well, I have to do the same thing, except I just have to do it with negative constant tiles. So that's 1, 2, 3, 4, 5, 6, 7. So if I add in 7 negative constant tiles, it offsets the 7 positive tiles. And then I can do the exact same thing on this side, and I can get rid of those. But I can only do that if I also add them to the other side, right? So I also have to add in these 7 negative tiles. How many was that? 1, 2, 3, 4, 5, 6, 7. Okay, so I've added in the negative 7 constant tiles. Now these two just cross out, so I'm going to redraw my equation now and see what I've got. Let's put this black. Now on this side, I still have those 5 negative C tiles. 1, 2, 3, 4, 5. And I probably shouldn't have drawn them this way, and I'll show you why in a second. So I've got 5 negative C tiles, which I will shade in. And then on the other side, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which makes sense, 3 rows of 5. I've got 15 of these constants. I'll show you why I should have drawn these negative C tiles slightly differently in a second. Because I cost myself one extra step that I really didn't need to. Okay, so now the variables are isolated. I've got constants on this side. Okay, and I've got variables on this side. And that's what I want. I'm not quite done yet, but that's what I wanted to do. Now I'm just going to take my eraser and I'm going to make a little bit of a break here, just so you know that this isn't the same step. So this will be the final step here. Now what I have to do is I have to break up whatever's on the constant side into as many rows as I have on the variable side. So what I needed to do is I needed to draw 1, 2, 3, 4, 5 to represent that each of these 5 C's is going to be able to contain 3 of the constants. So if I just drawn it that way the first time I was up here, I didn't have to do this step. So there's going to be 3 constants that are attached to the first one. And then here's going to be 3 that are attached to the second one, and so on. So by the time I'm done drawing here, I've got 5 rows instead of 3 rows. But they really represent the same thing. Up here I've got, 5 columns, and each column has 3. Here I just turned it into rows. I've got 5 rows, and then each row has 3. The answer is going to be the same either way. Now the problem is we don't really care about what a negative C is, right? So this is the negative 5C. Oops. This is the negative 5C on this side. Ugh, pen. Okay, just going to pause for a second to get my pen working. Okay, so I think it's working again here. So this is going to be our negative 5 C's. And then over here we've got negative 15 for our constants. And we don't care about a negative C. What we want is a positive C. So we got to flip all those tiles. And because it's negative on both sides, we can flip them all just to positive. So I'm going to draw this step out. But really you could have done it in between here and here. So I'll just draw 5 sort of small positive C's. Okay, and then each of those is going to have 3 positive constants attached to them. Once again, sorry, I kind of ran out of room here. But don't forget, if you've got a negative variable over here, okay, you want to flip both the tiles so that your final answer is in terms of a positive variable. So what this leads to, after all is said and done, is that each c, each positive c, is worth 3 constants. Now, if we solve this algebraically, it goes a lot quicker. Negative 3c plus 7 equals, oh, what is that? I believe that's a negative, or so that's positive 2c and minus 8. So we're going to do the same thing. We're going to take the same steps. We're just going to do it with symbols, with numbers, instead of using the drawing. So the first thing we did was we tried to isolate the variable by subtracting 2 c's. So we're going to subtract 2 c's from both sides, right? This was the subtraction of 2 c's. And then right here, we actually added the tiles, but in adding negative tiles, we're subtracting, right? So we're left with a negative 5c, okay, plus 7 equals, and then that cancels out, so I've just got negative 8 on this side. Then the second thing we did is we had to get rid of, what is it there? 1, 2, 3, 4, 5, 6, 7. We had to get rid of 7 constants from both sides, and we did that by adding in the constants on this side and by also adding in the constants on this side. But remember, because we're adding negative tiles, we're actually subtracting. So this cancels out, and we were left with the negative 5c equals, we're negative 8, and we're going more negative, so that's negative 15. And that takes us to this point down here. We've got the negative 5c, and we've got the negative 15 as a constant. And now in flipping the tiles and ordering them into 5 rows, okay, so in ordering them into 5 rows, what we're really doing is dividing by 5, dividing it into 5 rows, right? That's exactly what we did. We took this mess, and we divided it equally into 5 rows, and then in flipping the tiles, we were just dividing by a negative. So those two things together, dividing into 5 rows and flipping, is why we divide by negative 5 on both sides. Okay? And then what happened at the end is that canceled out nicely, and a negative divided by a negative was going to give us c equals 3. So algebraically, we did all the exact same steps. It just looked a little different because here we were using a pictorial model, using the algebra tiles. In here we were doing the symbolic version, but really we did the exact same steps. It just looked a little different. Most people are going to prefer to solve theirs algebraically because it's faster. You don't have to draw as much. But I think it is useful. In today's day and age, most of the experts agree that having a pictorial model in addition to being able to do the algebraic kind of helps connect the two parts of your brain, you know, the visual spatial element and the logic element. So it's something that does take a little bit longer, but I think it does help in the long run. So humor me, will you? Solve each of the following algebraically. Okay, so let's just keep the same steps, right? We want to isolate our variable on one side. So we've got a negative 5x and we've got a positive x. Well, let's just get rid of that x and bring them to this side for a change. So I've got 8. And I've got negative 5x minus another x, so that's negative 6x. And then I've got negative 22 on this side, and that cancels out. That's why we did it. Okay, so we've got our variable over here, but we've got it, we need to isolate it. Okay, we've got to get it alone. Currently there's an 8 there. So we get rid of a positive 8 by subtracting 8 from both sides. Then we're left with negative 6x, because that cancels out. And then negative 22, getting more negative by 8, is going to equal negative 30. Now we've got our variable isolated, and we've got our constant on the other side. We've just got to find out what x is instead of what negative 6x is. So we're going to divide by negative 6 on both sides. That cancels to 1, and 1x is just x. And then negative 30 divided by negative 6 is going to equal 5. And if you wanted to check this, remember, just check left side and right side. You got lots of time to check in this class, so you might as well use it. So this would be 8 minus 5, and then we said x equals 5. And does that equal, that's the question mark, does that equal negative 22 plus, and then x is a positive 5 again? So we've got to do order of operations here. Before we subtract, we've got to multiply. So it's going to be 8 minus 25. And again, we're still not sure if that's equal. And then we've got minus 22 plus 5 on this side. 8 minus 25, so we're starting at positive 8, and then we're taking 25 steps toward the left on the number line, is going to leave us with negative 17. And then we've got negative 22 on the negative side, and then we're going to make 5 hops towards 0 on the number line, which is also going to take us to negative 17. So this checks out. Next example, very similar process. We've got a few more like terms on this one, so I'm gonna do this to make sure I separate which are the constants and which are the variables. So I've got 2 variables on this side and 1 on this side. So I'm gonna bring this one over to this side. So I'm gonna add 5x over here to both sides. And what that's gonna do is, well, I've got 2x plus 5x, and I can do the other x here if I want. So it's 2 plus 5 plus 1 is going to equal 8x. Okay, and that took care of this guy. This guy canceled out. Okay, and then this guy as well. So we've got the 8x minus 9 equals 10 minus 3 left over. We've got to get this negative 9 to the other side because we need to get this variable isolated all by itself. So how do we get rid of a negative 9? We're going to actually add 9 to both sides. So I'm left with the 8x over here because that gets rid of that. And then I can do this all at once. I've got enough, I think you've all got enough math skills to do that. So let's just do 10 plus 9 is 19, minus 3 is 16. Then we don't want 8x, we want x, so we're going to divide both sides by 8. And what we're left with is x equals 16 divided by 8 is 2. So let's go over and do our quick check because we got time. On one side, we've got... I might have to erase that because I can no longer see it anymore. I usually cross them off when I'm doing the work, but I usually cross it off with pencil so I can kind of see through it. So on this side, we've got 2x minus 9 plus x, and then on this side, we've got 10. My pen is flaking out again. Just going to stop the video quickly, fix my pen. Alright, I think I got it back here. So this is going to be 2. And what's our x? Our x is supposed to be 2, if we're right. So 2x minus 9. And then it's plus x, so plus 2. And then on the other side, we've got 10 minus 5 times what we think x is, which is 2, minus 3. Okay, let's just make sure we remember order of operations. So this is going to be 4 minus 9 plus 2. Okay, well, I've got 4. I'll just do it all in one step. I got 4 here. Right? And then 4 plus 2 is 6. And then 6 minus 9 is negative 3. And then on this side, I've got 10 minus 10, right? So 10 minus 10 is 0, and 0 minus 3 is negative 3. So that checks out. You could have done that in 2 steps if you wanted, or 3 steps. But I was reasonably confident in my ability to do all that at once, and I think you probably are as well. So I'll give it a check. Observe the following. If we evaluate this expression using order of operations, okay, we've got 5, and then in brackets we've got 8 minus 2. Bedmath says we got to do the brackets first, right? So 8 minus 2 is 6. So we got 5 times 6, which means 5 groups of 6. And 5 groups of 6 is going to equal 30. We can also multiply the value in the brackets by the value outside the brackets, and we're going to get the same result. So this is really the idea that you can distribute this 5 through if you wanted to, and mathematically it works out to the same thing. It's multiplication, right? So if we distribute it through, we'd have 5 times 8, which is 40, and then we'd have 5 times negative 2, which is negative 10. So we'd have 40 minus 10 equals 30. We end up with the same thing. Now, unless you have variables, you're always going to opt for this one. If you just had constants, you're always going to do what's inside the brackets first and then multiply it by 5. But if you've got a variable inside the brackets, you can't do that. You got to remember to distribute. And you got to remember to distribute. Once again, this check here, that's actually not check with 3 numbers. That should just be check the right side and the left side and see if it works. Hopefully I'll be able to get rid of that before you go too far. Maybe you can download the new version. If not, don't worry about it, just cross it out. And just, if you want to make yourself a note, so check RS and LS for left side, right side. All right, so we've got variables inside these brackets, which means that we have to distribute both of these, and it should be the first thing you do, right? So 6 times 2x is going to be 12x, okay? And then 6 times 8 is going to be a positive 48, and that equals 2 times x is 2x, and then 2 times negative 1 is negative 2. So now we've gotten rid of all the brackets, which is what you really need to do in bedmath, right? and we're in a position where we can solve them as we normally would. So I've got positive 12x's over here. I'm going to subtract 2x from both sides, and that's gonna that's gonna keep me happy over here because I've got 12 minus 2 is going to be 10x plus 48 equals negative 2. Now I've got the x's. I want to get rid of the constant, so I got to get it to the other side. So I'm going to subtract 48. Okay, so I'm going to subtract 48 from both sides. Keep my balance. This cancels out, so I'm left with 10x equals negative 2, and I'm going 48 more negative, so that's going to take me down to negative 50. And then I got to divide by 10. Oops, not 10x. I got to divide by 10 on both sides in order to turn my 10x into just an x. So we got x equals negative 50 over 10, which is negative 5. And they want us to verify this, so I'm going to verify right hand, left hand. So sorry if, I actually probably don't need to do the chart thing. It's probably better if we represent it this way. Our right side was 6 times 2x. Okay, so what's our x? Our x is negative 5. So I'm just going to put negative 10 in there. And, sorry, why did I do that? Negative, oh, sorry, I've got more work to do in the brackets there. Okay, so the 2x was 2 times negative 5 is negative 10. And then also in the brackets, I had to add 8 for the left side. And then hopefully I've got room for the right side. And the question is, do I have the same thing as 2? And then x is negative 5, right? Minus 1. So do these equal? Well, let's, because we don't have variables in these, we're always going to do the brackets first. So this is going to be 6 times negative 10 plus 8 is negative 2. And does that equal 2 times negative 5 minus 1 is negative 6. Well, if you notice, I got a negative 2 and a positive 2, and a positive 6 and a negative 6. And remember, the order for multiplication doesn't really matter. Well, it doesn't matter at all. So I know I'm going to get the same thing. It's negative 12 on both sides, and that checks out. All right, next one. They are giving us decimals, which means we are allowed to use our calculators, and we are allowed to keep it as decimals. So let's just crank this out here. We got to distribute just like we did on the previous question, because we got variables inside the brackets. So 2.2 times h is 2.2h minus, and then, this might be the time to pull up the calculator, 2.2 times 5.3. Okay, so I'll just get the calculator out. 2.2 times 5.3 equals 11.66. Oh, pen. There you go again. 11.66. Then on the other side, we've got 0.2 times 32.9, and that gives us, times a negative 32.9, which gives us negative 6.58. And then 0.2 times a positive h is just going to be a 0.2h. Now let's bring for our second step, let's try to get all the variables on one side. So I'll subtract 0.2h here and do the same thing from both sides. So if I've got 2.2h and I subtract 0.2h, that just leaves me with 2h, which is nice and handy. And I didn't do anything with the constants. I scrabbled that out, and then I've got negative 6.58. So now let's get this negative 11.66 to the other side. So I need to add 11.66 to both sides to counteract that negative. So that's going to cancel out, and I'm left with 2h equals, and then I've got negative 6.58 plus 11.66, which is going to give me a positive 5.08. And then I've got to divide by 2 to get my final answer. And our h is equal to 2.54. At least I think it is, and that's why we're going to check. So let's check over here. On our left side, we've got 2.2 times h, which we say is 2.54, minus 5.3. Okay, I think. And then on the right side, I'm not going to have room, is going to be, you know what, I'll just do these top to bottom instead of side by side this time, just because I don't have room. Didn't leave myself enough room. So this side of the equation is 2.54 minus 5.3 equals negative 2.67, and then I got to multiply that by 2.2. So on this side of my equation, I have negative 6.072. Now that needs to be the same, okay, as the other side. So I'm going to say question mark, is that the same as 0.2 times negative 32.9, and then it's plus 2.54. Okay, so what's negative 32.9 plus 2.54, because it's in the brackets, I got to do that first. So this becomes negative 0.2 times negative 30.36. What's left in the brackets? So times 0.2 equals, guess what? Negative 6.072. So that checks out. Ideally, I write those side by side to kind of demonstrate left side, right side. I just didn't have room, so I wrote it below. All right, next question. Now we got a little bit of both, right? We've got brackets, but we also got some variables and coefficients and constants outside the brackets. Just make sure that this is the first thing that you take care of, all right? So this is an interesting question because we got a minus 3 minus 4x in brackets. Remember, that's always minus 1 times what's inside the bracket. So when you just have a minus sign, all it does is it flips the signs inside the bracket. So let's just rewrite this question. We have 6x, didn't change. Negative 3 times 3x is negative 9x. Negative 3 times 1 is negative 3, and then equals 14. Didn't change it. Now, we've got a positive 3, so that's got to flip to a negative, and we've got a negative 4, so that's got to flip to a positive. Right? Just multiplying by negative 1, all it does is flip the signs. Now we're back to the point where let's just try and get our variable isolated and see what we have. So over here, we've got 2 x's over here, we've got 1x, sorry, 2 terms with x's, so maybe it's a good idea for me to underline my like terms, or sorry, make a note by my like terms so I don't get them confused. Over here I've got 6 minus 9x, so that's negative 3x, minus 3 equals, I've got 14 minus 3 is 11, and then I still got that 4x to deal with. So let's subtract 4x from both sides. Okay, that gets rid of it on this side, which is what we wanted, and now we've got a negative 3x, and we've got to go negative 4 more, which is going to take us down to negative 7x minus 3 equals 11. And now I've got to get that 3 to the other side, so I've got to add 3 to get rid of the negative 3, so that's negative 7x equals 14. Then I want to get x alone, right? So I've got to divide by negative 7 on both sides. This cancels to be an x. And 14 divided by negative 7 is negative 2. Now, so let's check our answers. Okay, on the left side, we've got 6 times negative 2. Oof. Pen. 6 times negative 2, that's what our x is, minus 3, and then in the brackets, we've got 3 times negative 2, and then we've got all that plus 1. And do I have enough room to write the other side? I think I do. Equals 14, and then it's going to be minus 3 minus 4x. Remember, x is negative 2. There we go. So let's see. Does the left side equal the right side? Okay, let's do the multiplication first, right? And we've got brackets, so let's deal with all that. So 6 times negative 2 is negative 12. Minus 3. Now, I can't multiply this yet. I mean, I could, but I'd rather take care of what's inside the brackets first. So 3 times negative 2 is negative 6. Negative 6 plus 1 is negative 5. Hopefully I'm not doing too many steps at once. And then over here, I've got 14 minus, and then we've got negative 4 times negative 2, so that's going to be in the brackets, that's going to be 3, okay, plus 8. We'll just keep going through the steps here. We've got subtraction, but I've also got multiplication still, so I got to do the multiplication first. So negative 12, and then I got a negative 3 times a negative 5, so that's going to be a positive 15, negative times negative. Does that equal 14 minus, okay, what's 3 plus 8 is 11. So I took care of the brackets there. Now I've just got addition and subtraction, and hopefully both of these sides equal the same thing. Otherwise, we made a mistake somewhere. So negative 12 plus 15 should leave us with a positive 3. And 14 minus 11 should leave us with positive 3 as well. So this checks out. And again, it doesn't take very long to check your answer out. So You might as well do it. You got time. All right, let's do some more fractions here. We've got x over 8 minus 5 over 4 equals 2x over 3. Now, we've got to be super careful with these, okay, because we have been working with multiplication and division of fractions, but when we're adding or subtracting fractions, it requires a, excuse me, it requires a common denominator. And that's why, frankly, adding and subtracting is more difficult than multiplying and dividing, which isn't normally the case. Normally it's easier to add and subtract with just regular numbers, but when we got fractions, requiring that common denominator just adds an extra step. So what we need to do is we need to make sure that we've got a common denominator, and our common denominator with 8, 4, and 3 is 24, right? And you can figure this out just by writing these three numbers and then writing out the multiples of those numbers until you get one that matches, right? So 3 times 1 is 3, times 2 is 6, 9, 12, 15, 18, 21, 24. Okay, and then 4, you've got 8, 12, 16, 20, 24. I'm stopping at 24 because I know that this is going to be 16, 24. Okay, right? So the lowest common denominator is going to be a 24 on this one. All right? And so we need to turn each of these denominators into 24. And the way that you typically do that is just what do you need to do to the bottom to make it 24, and then you got to do the same thing to the top, right? So if I go 8 times 3 on the bottom, that's going to equal 24. And because I multiplied by 3 on the bottom, I have to multiply by 3 on the top. So 8 times 3 is 24, and then x times 3 is 3x. Right? And then the same thing on the next one. How do we turn a 4 into a 24? We have to multiply it by 6. So we've got to multiply the top by 6. We get 30 over 24. And then for the last one, how do we turn a 3 into a 24? We have to multiply by 8. So we have to multiply 2x by 8 to give us 16x. Once we've got that, now we can go to the get rid of the denominator, because we're always trying to squash the denominators, right? But we had to make sure we had a common denominator before we go any further because we knew it was a subtraction question. So once you know that you've got a common denominator for your addition or subtraction question, then you can do just what we did before. How do we get rid of a 24 in the denominator? We just multiply each one of these by 24. So that's what we did here. 24 times 24 and times 24. And you know that's going to cross out with the bottom. So there isn't really any extra work there, right? That's just going to cancel out, that's going to cancel out, that's going to cancel out, and you're really left with what's just on top there, which was 3x minus 30 equals 16x. At this point, you've got all the denominators gone, so now it's trivial. You can solve your question, right? So it's not going to be a very nice number, I don't think, here. I'm going to have to take negative 3x from both sides, so that leaves me with negative 30 on one side, and then 16 minus 3x is 13x. And then I got to divide both sides by 13, so it's going to be kind of an ugly little fraction here. But that's going to leave me with, well, negative 30 over 13 equals x. So that's an improper fraction. How do we solve that? Well, how many times does 13 go into 30? It goes in 2 times. Well, 13 into negative 30 goes in negative 2 times, right? And then what's left over? Well, if we put it in 2 times, we really put in 26. How do we get from 26 to 30? That's going to be 4 more, right? So that would be negative 2 and 4/13, which seems like a kind of a gross answer to this, but I don't believe there were any mistakes in it. Negative 3x, oops, minus 30, yep. Checks out. And I could sub this back in to the right side and left side to check if it works, but I don't want to spend that much time. I don't want to spend that much time with my fractions. So you're going to have to trust me on this one. And let me know by email if I got it wrong. Okay, so let's put that into practice with some of these equations here. Now this one, there's no addition or subtraction, so this one's going to be nice and easy. I've just got to zap that 5 denominator on the bottom. So in order to do that, I'm just going to multiply the top by 5 and just make sure you got to do it on both sides of the equation, right? So this one, I don't have to do any work. That just zaps the 5 and leaves me with the 2x. And then I've got negative 16 times 5, so negative 16 times 5 is, what is that, 80? That should be 80, right? So that's going to be a negative 80 and then I'm going to divide by 2 to get my x alone, and I should have x equals negative 40. So that one was kind of easy because it didn't really have any addition or subtraction. This one, not so nice, right? I've got subtraction over here, I've got addition over here, so I do need a common denominator. What is my common denominator for 5 and 3? Okay, it's going to be 15. Okay, nothing else we can do. Okay, 5, 10, 15. Well, 15 is the first one that works with 3. So the easiest way to proceed from this point is let's just multiply both sides by 15, because we know that's going to nix our fractions. And we've got to be really careful here. I think the easiest way to do it, is just to write your common denominator out front and then put everything else in brackets. So it's going to be 15 times 3 over 5 x minus 4, and that's going to be equal to 15 times 4. Sorry, that's not 4 on that side. That's 15 times, once again, this little equal sign there, 2 over 3x plus 1. And now let's work this 15 through these numbers, and it will get rid of our fractions, and we don't run the risk of not distributing when we put when we write it this way. That's why I like putting the entire common denominator out front with the brackets, and it just to ensure that we don't forget about the negative 4 and the positive 1. So let's look at this now. If we distribute across here, well, we've really got 15 times 3 is going to be 45, right, over 5x. And I know that we can simplify that, and we will simplify that in a second. Pen back. So that is over 5x. And then minus 15 times 4 is 60. So we might have some bigger numbers, but I think we keep ourselves in better shape. And then 15 times 2 is going to be 30. And then 15 times 3 is, you don't multiply by 3, just multiply by the top. Not sure why I was trying to multiply the bottom. Because remember, this is really 15 over 1. So it would be tops times tops and bottoms times bottoms. So it's 15 times 2, and then it would have been the 1 times 3. So that just leaves us with 30 over 3x. And then 15 times 1 is going to be 15. So it still looks kind of gross, but we can cancel our fractions easily, and that's why we did it. So 45 divided by 5, that's just going to leave us with 9x. And then we don't have to do anything with 60. And then 30 divided by 3 is going to leave us with 10x. And then we don't do anything with the 15. And now we've got a really easy equation to solve. Because I've got a positive 10x here and positive 9x, it's actually going to make more sense for me to bring the 9x to the other side. Okay, so if I do that, I cancel that. I'm left with negative 60 on this side. 10x minus 9x is just going to leave me with an x, and then there's a plus 15 that I can't do anything with yet. How do I get the 15 to the other side? Well, now I got to subtract 15, so I got to subtract 15 from both sides. Over here, I've got a negative 60, and I got to go 15 more negative, so that's going to be a negative 75, and that equals my x. So that should be my final value right there. I think the key point on that one is finding your LCD, or your common denominator, which is really the least common multiple, and then multiplying both sides using brackets to try and keep it straight. And this one over here, hopefully I've got enough room for it, because it kind of looks ugly too. Excuse me, I've got x over 5 times 2, I've got lots of stuff. Okay, but let's look at the denominators, right, because that's going to be our important first step. So our common denominator for 2, 5, 3, and 6, I'm just going to do it with my head, and I'm sure you can figure it out too. Let's start with the biggest number, and then let's see what we get. Because 6, well, clearly 5 doesn't go into 6. So what's our next number is 12. 12 works for 2 and 3, but it doesn't work for 5. Then we've got 18, same thing. 24, same thing. Then finally 30. Finally at 30, we've got a common denominator, right? Because we can divide 30 by 2, we can divide 30 by 5, we can divide 30 by 3, and we can divide 30 by 6. So that should work as a common denominator. Again, we might get some bigger numbers, but let's take the time to multiply everything carefully using brackets. So this would be x plus 5 over 2. And this is minus, same thing, 30 times 2x minus 3 over 5. And I'm going to run out of room. Then on the other side, we've got 30 times 8 over 3. And I'm just going to Move this line over a little bit. And what's our last term here? Minus 30 times x minus 1 over 6. Now, it looks gross, but at least it's well organized. This separated for my check, or for the question B. And now we've got to be careful. Remember, we're just multiplying these by the top, right? Just by the numerator. And I almost made that mistake up here. And we have to make sure that we distribute, which means this 30 has to go by both terms. Every time you see two terms, this one is fine, but this one is not. Every time you see two terms inside a bracket, so that'd be like a variable separating from a constant with a minus sign or a plus sign, because there's subtraction or addition, you got to remember to distribute. So let's do it. We're going to have a nice long equation here. 30 times x is 30x. Okay, plus 30 times 5 is 150. And my pen is deserting me again. 30x. Okay, sorry, I got to stop the video again. Why does the pen hate me so much? 30 times x is 30x. Plus 30 times 5 is 150. And that's all over 2. Remember, we didn't do anything with 2 yet. Then we've got minus 30 times 2x is minus 60x. And then we've got negative 30 times a negative 3, which is a positive 90. And all that is over 5. Then on the other side, we've got 30 times 8, so that's 240 over 3. And then we've got negative 30 times x, so that's negative 30x. Minus 1, so that's negative 30 times negative 1 is going to give me a positive 30. And all that is over 6. Now let's just nix the fractions, because we know we can do so. And I apologize again, I've got kind of running out of room here. Now, just like when we were multiplying and distributing, we have to do the exact same thing when we are dividing. Now, theoretically, we could have done it up here. We could have simplified the 30 and the 2, and simplified the 30 and the 5, and simplified the 30 and the 3, and simplified the 30 and the 6. And you know what? Maybe that would have been a better way to do it, but it'll still work out fine this way. As long as you remember, you got to divide both of them, right? So 30x divided by 2 is 15x. 150 divided by 2 is a positive 75. Negative 60x divided by 5 is negative 12x. 90 divided by 5 is 18, so that's going to be a positive 18. Then on the other side of the equation, 240 divided by 3 is going to be 80. And then we've got negative 30x divided by 6, which is going to be negative 5x. And then we've got positive 30 divided by 6, which is going to be a positive 5. I didn't make any mistakes there. We're not done yet. I got to go solve this still. I'm going to take this down over here and just rewrite it. So 15x plus 75 constant minus 12x plus 18 equals 80 minus 5x. Of course, I ran out of room. Plus 5. Okay, so let's start working with some of these like terms. So there's x's all over the place, and there's constants also all over the place. On this side, we got 15x minus 12x. Well, I know that can be 3x, right? So 3x plus 75 plus 18. So I got rid of that one, and I got rid of that one. Equals, and then on this side, I've only got the negative 5x. I'm just going to work with the 80 and the positive 5. So I got positive 80, positive 5, so that's 85. And then I still got minus 5x, so I got rid of that one as well. Okay, so I still got x's, and then the rest are constants. Let's bring this 3x, let's bring this negative 5x over to this side. So I got to add 5x, right, to both sides. It's just you know, following the steps and just trying your best not to make mistakes with your adding and subtracting at this point. 3x plus 5x is going to be 8x, and then 75 plus 18 is going to be 93. And then on the other side, I've got 85, and then I took care of that, so that should be gone. Take care of that. So now I've got 8x. Let's get it by itself. So what I'm going to need to do is I'm going to need to subtract 93 from both sides. Gets rid of this. 85 minus 93, well, I've got it's a bigger negative number than the positive number, so that's going to be a negative, brain's not working today, 8. That makes sense. And then we got to divide by 8 to get the x alone, and without a coefficient, and that equals -1. Geez, that seemed like a lot of work to get x equals -1. But as long as I didn't make any silly math mistakes, which is not beyond the realm of possibility, we should be in the good place. Once again, from this step to this step, you could have done 30 divided by 2 is 15, 30 divided by 5 is 6, 30 divided by 3 is 10, 30 divided by 6 is 5, and that might have simplified, down to this. That would have simplified down to this step right here, probably with a little less confusion over fractions. It's okay to do it either way. I chose this way just because I really wanted to demonstrate that distribution, but you would have distributed it anyway. So I guess the message is, if you see something like this and you want to simplify these by the denominator, you can do that. You'll get the exact same answer, but it's also okay to do it the way that I did it. All right, last example down here. Some teachers say if you have fractions and brackets in the same equation, you distribute first, then eliminate the fractions. I've never done it that way. I always want to nix the fractions as soon as I can, and I think you're much more likely to get into trouble if you start trying to multiply fractions by constants or variables. You're more likely to make mistakes. Excuse me. So I want to kill these fractions first, which is kind of what I was saying up here. Instead of making bigger fractions, let's try to get rid of the fractions. So I'll show you what I mean here on this one. All right, so let's look at our common denominator first. We've got a 9, a 3, and a 6. Okay, so it should be 18, right? 9 times 2 is 18, and 3 divides 18 nicely, and 6 also divides 18 nicely. So our common denominator is going to be 18. So let's get rid of those fractions right away. So we're going to have 18 times 5 over 9, which is also times 4x minus 1. Okay, we're not changing anything yet. I'm just going to get rid of the fractions. Okay, so then we've got minus 18 times the 2/3, which is also times the 5x plus 1, and we're not going to worry about that for now. We're just going to worry about getting rid of the fractions first. Probably should have written this a slightly different way. Let's just write it as a fraction out front, and then that was 4x minus 1. And then on the other side of the equal sign, I'll kind of squeeze it a little bit here. I've got 18, and then I'm going to multiply that by the 1/6. And then also at some point that has to be multiplied by the x plus 8. So the reason I wrote it out this way is I just want to cancel and get rid of my fractions right away. So before anything else, remember at this point we got multiplication here, and then we've got multiplication here separated by a negative sign. So it's this whole thing minus this whole thing equals this whole thing. But we know we have to do multiplication before the subtraction. So let's kill those fractions before we get to the subtraction. So if I look at what I got at top and what I got at bottom, because remember 18 is really just 18 over 1, right? So I can cancel what's 18 divided by 9? It's 2. So that was the whole point of that. What's negative 18 divided by 3? That's going to be a negative 6 now. And then what's 6 divided by 18? That's going to be a 3 now. So now I've gotten rid of all those fractions, and it should be a lot simpler. Now I've got 2 times 5 is 10. And then I didn't do anything with this yet, so it's got to stay there. And then I've got negative 6 times 2, which is negative 12. Right? So just multiply what's left on the top, because I know I killed the fraction. And I've still got this 5x plus 1 in the brackets. And then I know I've got a 3 times 1. So that's just going to be 3. I already took care of the 6 down there. And then I've got the x plus 8 in brackets. So I think that's the right way to do it, or the best way to do it, because I killed my fractions with the first step, and I didn't need to bring them all the way through each of these binomials in the second set of brackets. Now it's quite trivial, right? Because now I can distribute just with rational numbers that aren't fractions. So that's going to be 40x minus 10. That's going to be minus 60x, and then negative 12 times Positive 1 is negative 12, and then 3 times x is 3x, and 3 times 8 is 24. So our numbers are much more manageable now. Don't have to worry about fractions. Got rid of them early. That's the way I usually do them. So let's just start putting stuff together here. All right, so I'm going to put these things together. I got a positive 40x and a negative 20x, or negative 60x is going to equal negative 20x. I got a negative 10 and a negative 12, so that's going to be negative 22. And then over here, I didn't really touch anything because they're not like terms. Let's get the x's on one side. I'll just go negative for now. So I'll bring the 3x this way. Got to subtract 3x from each side, so that cancels that one. Negative 20, and then 3 more negative is negative 23x. And then I'll just write it out in 2 steps. Still got the minus 22, still got the positive 24 over here. So negative 23x, and then I've got to add 22 to both sides. And that gives me 24 plus 22 is going to be a positive 46, and that's going to work out nicely. Because now when I divide by negative 23 on both sides, this cancels to x. And 43 divided by negative 23 is a nice round number, no fractions, negative 2. So there were a lot of there were fractions in front of binomials on this one, and it took longer to get to the answer. I did throw in a couple extra steps I might not have normally done. But the most important part of this one, I think, is right here. Get rid of fractions first. Because if we do that first step right, then from step 2 on downward, it's easy for us because we're not dealing with any more fractions. And we know we're more likely to make mistakes if we use fractions. So word problem is going to be another day. That should take you through 6.2 and the text questions. As always, if I made a math error somewhere on my tutorial, or if I went too quickly on something or something doesn't make sense, please just email us and we will do our best to do another couple questions or send you a video or whatever we need to do to help you understand it. All right, best of luck.